Okay, so we're back here working on more development stuff. I'm not going to get into the sentries. I'm not going to do guns. What we're going to do today is program the reload system for Json. This will be a vastly important feature that will probably be overlooked by most people, but it'll let you edit the JSON data and hopefully reload it in real time. There is probably a couple complications with this, and we're going to have to hit them as we go. The first thing we're going to do is, because this is a very important functionality piece of it, I need to figure out how to get the JSON data to load without being considered a source file. Right now, how we're handling everything is we mark every resource folder as a source folder, but we want to mark the resource folders as resource folders. That way they're being indirectly accessed rather than being copied into the output folder. So we're going to test, the very first thing is we're going to actually test the sentry mod and see if it works. So I need to go find, I guess I'm already on it. So as we said, we work this way. We need to do this. And then we're going to see if this works. If this works, I will be happy. We're going to need to do a clean build. So we're going to rebuild. This will clear out anything in the source folder that was there previously, get rid of all the extra junk, and give us a brand new clean copy. Then we're going to test to see if our sentry guns load and everything like that. If this does work, then we can make the reload system. If it doesn't work, we're going to have to get more inventive. And I'd rather not get more inventive with things because that's how you break stuff. The more inventive methodology would be to create some kind of external folder. Do what we're doing for VoltEngine. So VoltEngine, for those who are not familiar with how we're building it now, is our Gradle scripts copy multiple submodules into a single source folder, then compile via that source folder. It's something I actually just fixed yesterday. Dmod got it mostly working, and then it broke, and neither of us could figure out what's going on, so I screwed around with it, and I got it to work somehow. Still have no clue how I got it to work. I'm not a Gradle tech. I don't know how any of that code works or any of that scripting system works, but just by adjusting a few things, it started functioning again. My suspicion is that in an attempt to make the code work more efficiently, some error was introduced that then broke the whole system as a large. So what I ended up doing is I got rid of, or I simplified the clean task. We had a clean task that wipes out old folders. I simplified that, and I simplified the copy task, which was designed to copy the source code files. Simplifying those two ended up fixing it, along with a few other adjustments. I also improved it so that way it doesn't delete the entire file structure and everything else. But it looks like it's finally rebuilt, so we're going to run debug, and we're going to see if the sentry guns load. If they load, we're going to switch everything over to the resource system, and that will give us a better handle of everything. We're also going to need to look at the console as it runs to see where it is loading these folders. If it is loading them from the resource folder, then it is functional. If it's still loading from the output folder, then doing a JSON reload is going to be hard because it's not looking at the actual copy of it. It's looking at its own copy, which means any edits we actually make inside of the workspace here will not directly reflect over. But we're going to have to toy with that and see how we can get that to function. It is potential by treating it as a source folder, it may actually copy it over into the output directory. That is a theory that we're going to have to test, but I want to test to see if the resource folder works. I want it to access the folders directly. This also ties into the in-game editor. When the in-game editor starts to work, I want it to save directly to the resource folder as well. So when you make your changes, and you hit save, it'll save to that resource folder and not what the alternative would be. The alternative is I would have to save it to the overrides folder, and it would only save your override changes, and you would have to still merge the two together. I do plan to make an external editor, and I want the external editor to be used more than the in-game editor. In-game editor will be used for fine-tune adjustments of models and stuff. The external editor should be used for everything else. And there will be really helpful graphical tools in there. So if you want to edit your models, it will render your model, it'll render the scales and everything. It'll show you what everything looks like, and you can adjust everything. So whatever you adjust in that will look the same in game. That'll also give you a much more controlled system, so you don't have to worry about AI code running or anything else. That's the main reason why I'm working on this now. Is we have things like the laser gun, which, by the way, which loaded. So the main reason I want to fix is see how the laser guns is not quite firing correctly on the position. This has to do with the bullet spawn position not being exact. It actually might be the aim is where it's thrown off at. We'll have to toy with this, and we'll have to figure out just exactly how this functions. Yeah. You know, I think it probably is actually the aim, because I think the bullet spawn point actually is correct. But the good news is it did load from the resource folder, which is what we wanted to do. It loaded our textures, it loaded our models, it loaded everything. That is exactly what we wanted to happen. So we're going to go through all of our projects and we're going to mark everything as a resource folder. That's supposed to be a resource folder. So resource folder. There's no resource folder in here, I don't think. Oh, there's a resource folder. Keep hitting apply as we get on through. Yeah, this will take a minute or two. Resource folder. Hopefully this doesn't break anything. I'm not exactly in the mood to deal with everything going screwball on me today. I already went up to the university to take an exam because I was hoping to get all of my schoolwork done today. Every last bit. And then I could spend Saturday and Sunday just screwing around. Although Sunday I do have to go participate in holidays. So at least my family's not being a dick about it. So let's see. Doo-doo-doo. By the way, what I mean by dick is I've been guilt-tripped into showing up to things just to be yelled at by multiple relatives for not having a job, not doing anything with my education, switching from being an engineer, because for those who don't know, I originally wanted to be an electrical engineer and told people most of my life that's what I wanted to be. I hit college and I found that that is not at all what I wanted to do because I misunderstood what electrical engineers do. I'm more closer to a technician than I am to an engineer. I think like an engineer. I can actually do work as if I was an engineer, which is really nice because it adds in a really cool mentality. But I prefer to do hands-on work. I prefer to be more practical, and I don't like the idea of just being designing. It's the reason I got into programming is because I can be the theoretical guy, I can be the design guy, I can be every part of the thing, including the practical. But as an engineer, that is less likely to happen. And plus, I got the living crap kicked out of me on the math. I'm not the greatest at math. I never have been. It is something I probably could have gone through if I actually cared enough. If I put enough effort and motivation into, I would have definitely probably got the math taken care of. As after all, I passed several semesters of calculus. I passed several semesters of calculus-based physics, chemistry, all the fun stuff. I got all of that handled. I only faltered a little bit on each of them, and because of that, I lost a little bit of motivation. The main thing was is I took a physics class that required you to do advanced electrical mathematics. So things like calculating the number of electrons that could be on the surface of metal. That was not exactly the easiest math I've ever hit to, and I went, if I have to deal with this constantly, it's not really worth the time and effort. After all, I enjoy making things more than I enjoy anything else. So I stuck with that. Oh man, I got so many mods in here. Trying to think of, I probably didn't need to fix all of these. Oh hell, Bone Torch doesn't even have a code base for some reason. Cardboard Boxes is missing its code base. Collared Chest is missing its code base. What the flip? Quite a few of these are missing their code base. Hopefully that isn't a major issue. Most of the important ones are here. I gotta get Magic Mirror updated pretty soon. I was hoping one of my interns, or rather junior developer Kalatra, was gonna take care of a lot of this stuff, but he's been MIA like normal, so I'm probably gonna have to update. Why is Red Bull's missing too? That was weird. Probably they got moved to a subdirectory and then I never updated them. Wooden rails, shears. Good thing is they're self-contained mods, so I don't really have to worry about them not being in the workspace. Some of this other stuff needs to be in the workspace. Like if I removed API, I would probably break the project pretty bad. Not just because it wouldn't compile, but you have a lot of other problems. Okay, resources, hit apply. Depths, Minecraft JUnit, Minecraft. Pulse engine tests, resources, okay. Okay, so we got this. Now we're going to go through and we're going to hit run debug again. I need to watch the console and see what the console does. So we need to see what folders it's loading JSON content from, because that is really important. If it loads it from the right folder, then we can keep track of the folder that was loaded, and we'll keep track of that on the JSON generated object. So that way, when we go to iterate through and we go, hey, what content do we need to reload when we call the reload command? It'll go, okay, here's your file, here's what you need to reload, and it'll go through and reload it piece by piece. It's going to be a little tricky. It's probably going to take a bit of changing to the base system to figure out how to do this. As the system is not designed to track what files, what stuff came from. It's not designed to read partial files. So if it reads a file, it's going to read the entire file. So that means we're going to have to create a system where we regenerate the objects, then we merge the objects together. And then we'll have to let the system decide what objects get merged. So we're going to have to make an interface called iReloadable, so that'll then define what properties are reloadable. We can then use our JSON injection system to handle the rest of that. So we'll go, okay, this is reloadable. We'll also, while we're at it, we'll go ahead and pre-implement the editor system. I will have to make the GUIs for the editor and commands. And most likely, a lot of it will still be command-driven. So you'll go like /ve JSON edit, the name of the object, the field name, and then the variable to put in. So it'd be like VE JSON edit, Sentry Laser, barrel length 1.3, and then it'll edit that field. And then you can go /save or something, /VE JSON save, so to save all modified files. So files will keep track when they've been modified by the editor, and then it'll save the modified ones. The trick is how to get this to work, because once again, the system's not designed to read partial files, which means it's definitely not designed to save partial files. So that means we have to edit the entire file. So we're going to have to read the file in, look at what was changed, and then merge the changes in and then resave the file. Means we're going to have to make some kind of system to turn objects back into objects, and a lot of little things are going to have to happen. So everything's still loading. So the resource folder is working, but we have to keep scrolling up because I'm looking for where the files are read from. Okay, here we go. We're still reading from the production folder. That is not what I wanted to happen. So the production folder is here. So, Now, if we go and we edit this, so if I do this and I hit reload, will that reload? No, there's no classes reload. So this is going to not work. And it's unfortunate. Could do a copy task. So I could write a piece of software that after the application is closed, it goes into this output folder and it copies everything back out. I could symlink things too, but I feeling like that would break. Let me scroll down and see if it loaded everything from everything. So yeah, it did all production folder. That's really unfortunate. It seems to out folder, could not locate any. How to fix this? So we wanna do something with this. I'm trying to think. I was about to Google and see if there was a fix for this, but there's no easy fix. There's nothing we can just do because what's happening is it's compiling and it's pulling the resources into the compile jar. Now, when we go to make an application, the way we can get around this is if we were making something that wasn't Minecraft, is we just tell it, okay, here's the resource folder, here's where you load it at, and that would work. And that means that game I'm producing, the editor for it's going to be by far easier to build. But for Minecraft, because it's going to be loading from a jar file, we have to do a system for this. This means we have to do things via the external folder system. So our reload system is dependent on the external folders. So we are doing overrides is what we're doing. So we're going to have to make it do the override system. So that means what we're actually going to implement is the overrides. And that also means we're going to have to create some way to take the overrides and merge them back into the main system. I'll have to think of how to design that because that's going to be complicated. For starters, we're going to work on the overrides. That's how we're going to do the editor in game. And we're going to just have to work on that. I can't think of how to actually make this function. So this is going to have to be in the core. It's going to have to be part of the JSON loader. And it's going to have to load from the external. So we need to create a system called overrides. And we need to create some kind of way to implement the overrides. And we need to create some kind of system to track how to implement the overrides. So we're going to make a folder just and call it override for the moment. We're going to need to make an annotation system. JSON override is what we're going to call this. I need to go look at other JSON systems real quick. Okay, so that's how we implement that. So by default, when you put this over here is how you can override it. So you may not have to do anything with it. So I can't think of... So we're going to require this to be programmed via the processor, the JSON processor data. Can we extend things? Is that actually a thing that can be done this way? So we want to go extends JSON processor data. No, can't do that. Okay. So we're just going to insist it has to have a JSON processor data, which means it has to have a value and it has to have a type. And we'll handle it that way. And we'll just go, okay, if you put this way, then this means it can be overridden via the external JSON data. Of course, there will be specific override designs. So there'll be like recipe overrides will be one. AI overrides, anything that's vanilla. So anything you need to modify vanilla-wise will be overridable. Technically, recipes are already handled. You can add recipes and remove recipes already. So I don't have to do anything with that. What I have to do is come up with a system to handle the overrides. So there has to be an override processor, and the override processor has to run last. So this works out for us pretty good. So we're going to make this really quickly. So it'll be JSON override processor. And this will extend the JSON processor. And JSON override data extends JSON gen data. Create the constructor. Of course, we need to implement methods. Okay, so the mod is going to be references.domain. This will be called override. And we got to think of how we're going to do this. So we can enforce that each independent object is handled its own overrides. Primarily via the injection system is how we're going to do most of this, but I'm trying to think of exactly how to do this. We're going to put load orders and all. You know, we don't even have to force this to run last. We can put an implementation here. So implements I load complete. Actually, this will go on the gen object. So be implement methods on load complete. So we'll handle all of our stuff on load complete. This is after pre-init runs, this is after init runs, this is after post-init runs. So that means everything is done except for recipes. There is a lot of the recipe stuff for the JSON does load and load complete, but these overrides aren't designed for recipes. These is going to be designed for modifying tiles, sentry guns, stuff like that. So we want to implement the system. So we need data. So we're going to need some kind of ID. So we're going to string string content ID. And then we're going to need data. So we're also going to need store type. And we're just going to straight out load the JSON object up as the data. This will get us started. And this won't require much to work with. I need to get the, where's the process? Oh no, wait, we're creating the object. Okay, so we're gonna need, and we're just gonna pass this all via the constructor. We're not gonna do anything complicated here. String type, JSON object, data. Nope, I want object, not override. And we're just gonna go set this all. Content ID equals content ID, this dot type equals type, this dot data equals data. Here's where I actually need to get the process method. Right here's what I want. And this will implement JSON override data. We put this here. Of course, we're going to have to rename that D method to the JSON override data. So we're going to need to ensure values exist. We're also going to need the object. And we're going to go JSON override data equals new JSON override data. This, and then we want data.get content ID get as string. Then we want data.get type get as string. And then we want data.get as JSON object data. That pretty much does everything. We could actually just do this real quick. Really quick JSON processor. Not much going on with it. That handles basically all that. And here's where we're gonna have to handle everything. So we're gonna need some kind of global system for tracking override injection keys. We're gonna need some kind of global system to track pretty much what objects are what. So I think we already track this. Okay, so here's our JSON data, processors, gen objects. Okay. So we could just go through the gen objects. And we need to get keys from the gen objects too. So really, each gen object should only have one entry on it. So what we're going to do is just add an entry like this, string get content ID. So a unique ID for this content. We're going to hit build because this is going to probably error out in so many different spots, but it'll give us what we're looking for. So block base is going to be pretty easy to get our content ID because it pretty much already contains the method. There should already be something down here for unique, because when we go to register, this is pretty much what the registry key is. Okay, registry key. Cool. And then we just got to work through each object. So item.json is the same way. It's pretty much registry key is what we're looking for. This is just going to use the ID system. Okay. Some of these are not consistent. Some of these should be. This is an abstract class. Okay, crafting recipes really don't have IDs. We probably could implement some kind of ID here. Yeah, I'm just going to return null. We'll assume anything that returns null it does not have a content ID and therefore cannot be used in the override system. So that's how we're going to handle it, so just null. Same here, pretty much. Okay, hit build because we're going to have to get more, there's more errors. By the way, the error window is showing up on my right screen right now. I'm working my way through it. Okay, render data has a unique ID, at least it should have. So yeah, it's called content ID. There's only one render data set per object, so we can literally just use its content ID. The reason why these don't have to be fully unique, by the way, because we're recycling IDs from other things, is that they're sort of unique per object. Actually, effect layers don't have content IDs, they're not overridable. We're just going to throw some of the stuff in here. We're going to implement keys for the models, though, just because, well, I can. This does not have a key. Or name data doesn't have a key, can't override or name data. You can remove or names and you can add or names. That's not. Same with texture data. Remove or add stuff. No override key. Same with audio data. No override keys. Okay, we already got that one. I don't know why that was listed twice. World gen data doesn't have an override key. These can be enabled, disabled via config. Effect list, same way. Not going to let override data exist. Because a lot of this stuff, like a lot of the graphical stuff, needs to be handled via resource packs. Replacement recipe, same thing. That's basically what's used already to replace recipes, so we're not going to edit it. Block data. I guess we can do registry key through this. Gonna hit build and see where we go with this. Should be more of these. I'm actually gonna close all now. No, this needs closed actually. Build, make project, close all. Something's weird about this because I should be getting errors from all the JSON gun data. Course IntelliJ is probably doing its normal thing where it's not compiling properly. You'd be amazed how often this happens. Thankfully, they have a full rebuild option. If they didn't have that, I wouldn't know what to do. But keep going with this. So we get all these keys injected. We then iterate through the entire list, and what we're looking for is to match that content ID for the type. So the type will be like block. So you're making an override for a block. And here's what I was looking for, by the way, override keys on this stuff. The cool thing is, what I can do with this real quick, is I can go to the armory entry, and this already should store an ID. So if we go like this, then we just have to pass ID back. Actually, there should even be a method for this. There should get unique ID. And we're going to copy this and we're going to put this down at the bottom. Okay, if we hit rebuild, we shouldn't have to implement anything on the armory objects because we rebuilt that. And we still have errors. Oh, because the damage types have content IDs. Do we want to allow damage types to have things? Because damage types don't have keys. They don't have unique IDs to them. And I don't really feel like implementing unique IDs, so we're not going to do that. So we're going to grab the content ID, bring it back to the damage data, throw it at the bottom, and we're just going to return null. Return null. Okay, that'll be an add override as well. And we'll hit build. We may come back and add IDs to this damage data, so we'll allow people to decide if they want to override damage data and stuff. How we're going to handle overrides for damage, though, is it's going to be handled on the munition itself. So the munition is what you would actually pass in to change the type. And we'll have to come up with unique ways to handle this, because there's can be additions, removal, and replace. So that's our three types we have to handle via overrides. Because if you just want to add data, so if there's an addable data system, then you can add data that way. So we're going to need to actually go back to our processor here, or our data. We need another type. So we're going to call it process. And we'll go over here, and we'll enforce it. It needs to be required right now. So right now the process would be add, remove, replace. Later we may decide we want to extend upon this to modify, balance, scale, replace if exists. So there may be like a system where if this mod's installed, replace here. You guys get the point. There'll just be more stuff to do. Do this dot process equals process, and we'll come down to load complete. So we're going to go if so actually we're going to store process to lowercase, and we're going to store type to lowercase and content ID to lowercase. So we're going to go if processed, or we actually want to do it the other way, so in case we get some weird effects. So we want to know if we equal add. So we have add data. Then we want to know if we got remove and replace. So remove data piece. So remove will reset to default basically, and then replace will change the value. And that's how we're gonna just handle things. And we'll do an else real quick, and we'll go okay, throw new illegal argument exception unknown process type for override. And we'll pass back type in here. And that'll give an error real quick, so we can do that. We're going to code replace only right now, and I'll handle add and remove later. This is where we're going to go to our annotation. So we're going to go types. Actually, we need to... I think this needs to be called value, actually. So we'll go here real quick. If we call it value, we can then default it. So we'll go value. List of supported value types for override. Add, remove, replace. We then want object default. We're going to need a couple of things here. So we want default value, invalid type object for annotation. Oh, come on, you. So you won't take an object as a default. Then how am I meant to handle this actually? String. Default value for input must match type as string. And then we want to do string, actually no type. applied to fields that can be injected with at link JSON processor data and can be overridden by external JSON data. Overridden, I think, is how you spell this. Spelling change to, yeah, it's overridden. Can be overridden by external JSON data. Okay, so we got our value. So we got what types we support, and then we got our default value. So what is our default value going to be? So if you call a remove call, you do that. There's one more thing. The problem with the add call is that it's a little tricky to handle. Okay, so we want to do a string. So we need a supported value type for this. Each method can only have one type. If add, it need. Actually, yeah, that works. Default value for input must match type of string. Only used for. Actually, we don't need this. So if it's a remove call or it's a replace call, it needs to handle its default on its own. So if we go to call to remove something, then there's going to be no method signature. We're going to note that. So add and remove each method has type. Add will pass in data to add. Remove will have no params. And replace will pass in new type. Okay, so that'll work, and we can just annotate with that. So we're going to need some system. We're going to need some kind of global system to track our override tags, which means we need some kind of global system to track this, pretty much. I think. This is going to be complicated. So we're going to need an interface called iReloadable, or yeah. Yeah, we'll make a new package for reload, and we'll handle reload later. So reload, and we'll put an interface in here. So we're going to make a Java interface, and we'll call it iReloadable JSON. And then when it comes to the override, and then we're going to make an interface called override or modifiable JSON. Yeah, that sounds good. Applied to processors that support modifying data after content has been loaded. So we'll let the processors handle this. And that means the processors are going to handle the override keys, I think. So it's complicated. So we're going to need a method called void apply modification string key object data. We want object data and string key object data, and last thing we actually want is whatever the thing is. So this would be D extends I JSON gen data. This will be D generated object. So this way we can just call things and it'll handle it, and then it understands how to do its own injection thing. This is part about having where processors register themselves with the keys. We're gonna have to go get the processor. We're gonna have to see the processor allows modifications. The processor allows modifications, and we need to figure out what data can be modified in the gen data. So it's a lot of work. This means our injection system is gonna have to keep track of fields. The good thing is we don't have to register these separately. We know it works. So we don't have to do anything with that. We can re-grab the annotations from the fields and from the methods in our handler. Oh man, so this is a lot of work, and I just got poked with something here. Oh, somebody commenting on ICBM Classic poking at him. I don't care. By the way, this is here. Let me just drag this to my screen real quick. It's like, not sure why this exists when there's Defense Tech. It's like, the thing with Defense Tech is, it is a clone of ICBM Classic. Not even like different code. It is literally the copy of ICBM Classic with changed data. Nobody seems to understand that. They think Aiden made a new mod. They think he just got inspiration from the whole thing. He literally came to me and went, hey, can I update the old mod and do stuff? And I'm like, sure, go for it. I don't really care what most people do. I do request that people ask permission to utilize code because I need to know what people are doing. This is because of the ideal that there are people out there that do malicious things. Aiden is technically one of those. I still do trust him enough that I let him do things. But he proved me right when I let him do this, is that he went off, he updated it, he made a direct clone. I'm like, hey Aiden, I told you when you did this you got to make your own models. He then attempted to make his own models. He didn't update everything. He made a couple models. Then he just dropped the whole mod. He hasn't really done any work on it. And I'm like, really, dude, you wasted my time doing this, and now people think there is another version, and I know exactly why he did it. He did it to grab more users. When he made Mechanism, this is what happened. He pulled a lot of users away from the rest of the team. It's why we kicked him out, is because he was glory and fame hoarding. When we made a Universal Electricity, that was not the design of Universal Electricity. We didn't want to have that happen. So we kicked him out. And then he goes and he does this, and he grabbed up ICBM to fame and glory hoard again. And we see the result of it is that he made a version that sort of works. It's not perfect. It needs a lot of work. I mean, I admit my ICBM Classic needs a lot of work too, but I even say this when I made it. I made a quick and dirty port so you guys can play the version, and then I'll come back and rewrite the whole mod like I did with ICBM, except I will leave the original content as is and only change the backend, and you guys will notice no functionality changes. Back to this, because I don't want to do a whole story about this, because I'll get angry and I'll go back to hating Aiden again. I mean, there's a lot of reasons why I hate him, and it's not, he didn't deserve any. Let me phrase this. When people think he doesn't deserve it, he actually had earned that. I made multiple attempts to work things out with him. So back to this whole system. So we're going to need to get the processor. So JSON processor equals JSON content loader dot instance dot processors, come on, dot get, and then we want type, I think. I need a rename type actually. So this will be processor ID. And the reason we're going to rename this is because it's ambiguous, or however you pronounce the word. I struggle with this. It basically means it's hard to understand what it means. For computers, this is really bad, but the computer does understand the difference between them. So that's not what I'm meaning. I'm using the word because humans had that trouble. Just like a computer, if you give it two things that look almost identical, it'll go, which one am I supposed to use? A human being will do the same thing. You give them two things that look almost identical, they'll go, wait, they look the same, which one am I supposed to grab? And they'll just guess. Same problem with a computer as a human being has. If you have to guess, you're doing it wrong. So in order to prevent guessing, you change things, which means I have to change the ID here. And this will be processor ID. Processor ID. So processor ID, and we'll call this action. That actually makes it even more easier to understand. So you got the content ID, so you know you're looking for a content, you're looking for a processor ID, you're then looking for an action, and then you're providing data. So it's a lot easier to understand. And it's one of those things you got to kind of think about when you design products is what is the best way I can portray my data to have the least confusion. So we want to go processor doesn't equal null. And of course, I'm going to throw an exception. We can't find processor. Unknown processor. Unknown processor. We throw in processor ID apparently because I don't know how that happened. This is action. No, action. I don't know how you got stack from that. Okay, it's called process apparently. So we need to rename you. Action. Exclude comments because we don't care. Exclude. I need to find a way to turn off comments by default. So we go unknown action type for override data. Override data. And of course, this will pass in the whole thing automatically. Next thing we want to do is we need to get the list of content. I'm going to modify the processor here in a second to make this easier. I can't do that. What is the complexity of this? O of n. So this won't be too bad. So we need to find our JSON entry. So I JSON gen object. Object equals, set it to null for start. Then we're going to go for I JSON gen object. We also need to do another thing. We need to go JSON content loader dot instance dot my brain just failed on me. I need the gen objects. Okay, so generated objects. Okay, so we want to go get processor ID. So that's how this system works, by the way, is it's designed that this is a list of objects generated by processor, and then here is list of processors for the handle file. So this is a processor ID, I believe this is also a processor ID. So we want to make sure this doesn't equal null, because if we have a null thing, we can't work. And we're going to pass a simple error for this. So this will be no generated objects listed for processor for override data. List of processor to find content by ID, and we'll pass in the content ID. So this will help whoever designed the override to use the override. And then we want to go here, so this will be object, and this needs to be, we're going to call this gen object because it needs to be clearer what I'm trying to look for. And then we're going to grab this, and this is going to be put here. And what we're going to basically do is we're going to loop over it and we're going to get the thing. So we're going to go if object doesn't equal null and object dot get content ID doesn't equal null. Actually, we can do it this way. We want to go if content ID equals, ignore case because content ID should generate via so we want to go object dot get content ID, then our gen object equals object, and we break out of the loop. So now we want to go if gen object doesn't equal null. Yeah, this is a lot of just backend data stuff. I apologize if you guys find this boring. I find it boring too. I'd rather be making content. Could not find content by ID, content ID in processor data list from processor ID. Actually, we're going to do ID for this one. We're just going to do processor, and we'll do processor ID. This will help people figure out if they messed up. So say you mess up the processor ID, and you're looking for a content. So you know you were looking for, say, like block tree, but then you accidentally put item here. This will tell you, oh, I screwed up and put the wrong thing there. So you want to make sure you try to give users as much information as possible. Okay, so we know we have an object now. So now we need to, actually when we're up here, we need to do another loop thing. So we're going to go processor instance of iModifiable JSON. And we're actually going to put this on the whole outer loop here. Put it out here somewhere. I hate doing these whole outer loop things because we're starting to get confusion of where things are. And we're going to go processor, and we're going to give the processor ID. Does not support modifying JSON data. Okay. So we got that, found that. Now we get to handle things. So we're going to switch this to this. No, actually, modify JSON data. So we're going to make a thing called add data. Remove data. In the case of remove data, we don't need to pass in any data object. We just need to pass in the key, what we're going to remove. And we want to replace data. By default, everything is going to be pretty much replace data. The other two are special cases. They're like if I want to add a damage to a weapon. That's where the special case is. Remove is also a special case. It's where I want to reset something to fate or remove a damage. So if I want to, like, say I'm an admin, I don't want to disable all my guts. I want to still let you craft them for, say, display purposes, but I don't want you to shoot each other with them. I can remove all the damage off the weapons. It is a possibility. Okay, so we want to do this. So now we want to go, okay, processor dot remove data. We need a key. So our key is what? Our key is, of course, the data. How do we handle the data, though? Complex it is. So we could change this around a few ways. So we got a content ID, processor ID, and action. We could remove the action and we could put it down into the data, and that lets us handle things differently. So we've got to handle this in a certain order. We need to run all the remove first, then run all the replace, then run the add. So we'll do that later, because right now the only thing we're concerned with is how we're doing this in the current path. Okay, so where were we at? Actually, this would be add data. So we're just going to have the loop over it. So we're going to have a JSON. It's actually a JSON entry thing. No, that's my own custom system. I could actually utilize it for this, maybe. So we want to get data dot entry set. And then we want to literally just want to go entry dot get key. I think that's how we're going to do it. actually, we gotta do it this way. So this has to be a JSON element, which means we gotta change this. Which means I gotta go to the processor. This needs to be just a get call to data. The reason we're doing it this way is I need to handle it in a specific way. So when we call an add call, it has to be an array. So we want to say it's an instance array. So I need to actually gonna clear this out. So we're gonna go data instance of JSON array. Else we throw an exception. I'll read that in a second. So data for add action. Actually, add action must use a JSON array for providing additions. And we'll do the same thing for remove calls. Data for remove action must provide this. And we're going to put this down here, but this is going to be a JSON object. The reason we're doing a JSON object is replace is literally you're going to create the object as you want to see it, and then you handle it that way. So this will be data for replace object must be a JSON object, and that'll work. So now for this, we just want to go for JSON element data dot, just data, and we cast it real quick. Oh, come on, don't be weird. There we go. And we loop through it. So we want to go processor dot add, and you want to get element dot Okay, so these need to be JSON objects. So JSON object. Because I need a key-based system, so cast. And then I gotta do some complexities here. So we gotta do map.entry object. You know what? Do it this way. We're gonna assist add calls are actually objects. This will make it actually easier. So this will be add action. Everybody in the world's gonna bug me for the next 2 minutes. Map.entry. This will be string.json element entry, and then data. Of course, we need to cast that, but it'll cast it automatically if we do a method call on it. Do that. Import class, and then we're going to do this again. That's why I said I had no clue how I was going to implement this, so we're kind of going to bounce around until I kind of get it figured out. So JSON to get value, and then we want to pass in our object, so gen object. Cool, this will work. It is an instance of iGen object. Oh, we screwed up the interface. Since it's iGen object, not mod. Okay, that worked. So this is how we're going to handle this. This actually means when we go to do this, what we're actually passing in for the data is JSON element. This means that the processor is going to have to handle the element on its own, and we're actually missing a key here. I need a key. Okay. So this is really just going to make things complicated. Is the easy way to put it. Okay, so it works. And then in here, we're going to just do this later. To do later. We need to get some progress going. We're already at an hour in the video, so it's going to take a while. Make sure I type in that to tell a couple people what I'm doing. So we got a huge processor here that handles things. So now we need to implement things on objects. So we're going to prototype this, and the first place we're going to prototype this is on the Sentry processor. And I need to register my override system. We're just going to register it down here. So we're going to go add new Json override processor. Not a very complicated system. Don't really have to worry much about it. Cool, that works. It should load up. Hit cancel on that. Hit armory. Content. We want our JSON. We want our processor. We want our Sentry processor. So we're going to implement modifiable JSON. Of course, we got to pass in JSON processor. And then implement methods. So how to handle this? So right now, we're going to do this. So this will be, why is that using processor? This is wrong. This is JSON data. It actually should be Sentry data. And this would be Sentry data. And of course, I pass that into every single one of these. These are all messed up now. So we want to pass in the key, generated object, and then we want to pass in data. Data should auto-process for us. And this will hopefully work. So this will be injected replacement override. And then we'll do that. We are going to handle add call right now. We do need to do one thing real quick. We're going to do this, Boolean override. And we'll make a second method for this. And we're going to do this. We're going to return handle. So this would be object to inject, key value, value to inject, and false. So by default, it's a false call, whatever. You get the point. So this will pass into this, and we'll use the override really quick to determine if our system has said filter thing. We'll handle this here. So we're gonna go. We're gonna make some things. So we're gonna make some kind of system, and we're making a method. So we'll make a method here. So we're gonna go public boolean supports, and we're gonna go string key value boolean override. So this is gonna be this. So we're gonna go if. Of course, we're going to have to do it this way. Actually, we don't need to do it that way. So this should be automatically lowercase. So if it contains either one of those, this will be return false. This will be return true. And we want to go if override. So we want to place this really quickly with a can support call. Or supports. Injection key override. Say we do it this way. So we go injection contains that. Then we want filled equals injection fills.get key value annotation. I don't know. How do we get annotations up here? So we want this, and we want that. and we want to go if annotation is instance of JSON override. And of course we need to do something else here. We want string override type, and then we're just going to do this real quick, and this will be string override type. Complex this is a good way to put it. So if we just do this single method system, it won't really work with the current injection system. The current injection system determines that each method or each key should only have one method, because it doesn't allow multiple methods to be handled for each. So that means this system's designed the same way. So that it really means we should track override keys separately. This won't work. We're going to need a separate way to track this stuff. Pretty much almost a separate system, which is dumb. Right now, what we're going to do is we're going to go, okay, if you have JSON override, we're just going to treat you as whatever. So we're going to return true, and I will remake this system later when I figure out how to do it, because that's the only thing I can think of. So we want to, of course, return false down here. So if we're checking for overrides, return false. This is a method system check. So injection methods. Surprisingly, this is literally the same code for each one of them. So we're checking for this annotation. If you find the annotation, it works. We're still going to pass an override type because I'm probably going to change this, and how this is going to change is I'm going to have to keep a global list of override methods separately from inject methods, but the inject methods set is going to be the same. And what might end up happening is I might keep multiple inject methods per variable now, and that'll allow different type assignments. I have to recode this whole thing down here in order to support that, though. So this would be true, and this would be add. And we're going to do this for all of this stuff. This would be null. And this would be remove. And this would be, okay, that's add. This actually replace. Replace. Injected. Remove override. And then we want to inject add override. So that should handle and we'll be able to override data externally. Trying to think of how to test this real quick. So we need to go to the external folder. Just how to start this. Okay, so I need to put something in here, and how we're going to do this is I need to go find the sentry gun. So it'd be armory here, content, And we want the laser sentry gun, so we want to copy this, paste them here, edit, and we got to get rid of some data here. So the part we want is, of course, the sentry gun, except it's not called sentry gun. This will be data. We need to create another one called override. I can hear dogs barking outside. Huh. Not like your normal dogs either, almost like search dogs. Weird. So the only thing we want to modify is barrel length. That'll be the variable we'll start testing with. So we got data, we got a barrel length, and we're going to make a barrel length like 5. That's be, I mean, a little outrageous, but it's a good test. And then, of course, we need to put our rest of our IDs in here. So the data required for this, content ID, processor ID, and action. So pop this up. So we need content ID, which would be laser sentry. I gotta go find the file again. So this beats ID. Okay. Then we need processor ID. This would of course be sentry. And then the last thing we need is action. And this would be replace. And we'll see what happens. So we're gonna hit run debug. If it breaks, then we cut this video and I go fix it, and I'll be back later because this video is too long as it is. I mean, you can't have every day where you actually end up making good stuff. Oh no, we failed. We failed because this system expects. Actually, I need to go here, not the test runner. This system actually tracks the number of processors we have because it's actually supposed to know what processors are there. Oh, more requests on LinkedIn? It's weird as ever. I'm suddenly getting a whole bunch of requests on LinkedIn from people I actually have no clue who are. It looks like it's loading so far. You know what we should have probably did is put a break here somewhere, so we can actually see this process run. It might be too late to actually do it. Oh no, we're actually in the early phase. We caught it in time. This actually won't work. I forgot to do something. We're gonna hit break real quick because it's just gonna waste our time. I gotta go here. And I need to do this. What I might do is I might just edit the JSON processor data keys to say what kind of actions can be performed on them. Actually, that is probably the best way to do it. Not quite that way as I'm thinking, but we can create a couple extra annotations. We can create one for remove, one for add, and one for replace. Add and replace would function almost identically to each other because if you're adding something, you're just calling an add method. And if you're calling replace, you're just calling replace. We would of course have to create methods that are designed for add. So the damage type, for example, which is one of the only things that would be an add method for, would be to add damage types or item stacks. You would have a method that was already susceptible to having an add call be called on it. So all you have to do is identify it as an add call, and we crashed. File is missing, content ID. Value data, what? Oh, that's what I put it in the wrong spot. Not exactly paying attention today, am I? Need a formatter. JSON data is all fugged. Looks good. Yeah, that'll work like I was saying previously. So we create some kind of system where we can identify this is an add, this is a replace, this is a remove. That way you have separate method sets for this. And how the remove would be called, and actually, let me rephrase this, we wouldn't have separate methods for this, they would all still be the same method, is when you call remove, it's actually an add call with a default number, or it's a replace call with a default number. So you would pass in some kind of default is how you would handle it, I think. I'll toy with it more. I'll do this later because I have to go probably think through the design, because clearly I started this video with no design in mind. So I missed my first step of when it comes to programming. That's come up with a solution. We dove directly into making functionality, which is cool. It's a good practice for prototyping and stuff. And what we're doing is prototyping the system. But we're toying around with this. And I mean, the whole original idea is I wanted to create the in-game or start on the in-game editor and start on the reload system. Reload system's out of the question because now we have to use the external system. But the external system has to be handled via overrides. A lot of work has to be done. Keep working on this though. At least I've got the override system out of the way, which will allow a lot of cool things. It means you guys, when you load up the mod and you go, I don't like the way that works, pop the override open and you just mess with it. It'll basically be controlled though, so I'll have to control which things are overrideable. Most things will be overrideable. Anything that has an injection data will probably be overrideable. You won't be able to change like content IDs, you won't be able to change localizations and stuff. Localizations are stuck in place. Okay, it's working. I didn't see the data call set run. Probably something didn't work. Yeah, I didn't see this trigger. Unload complete didn't run. I don't understand why. Oh well, I'm just gonna end this video. I'll work on it later.